Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. May all the peace and blessings of the Almighty Allah subhanahu wa ta'ala be on all of us. Now today, as you can see, I want us to dive and navigate through the functions of the liver. I may not cover all of them. As you can see, we have three: regulation of blood sugar level, we have the deamination, and we also have the hemoglobin elimination. Now, let's look one by one class. Now, the first thing is functions of the liver. Now, liver is the second largest organ after the skin, and it is a vital excretory organ, and it is located beneath the diaphragm. And therefore, the liver is being supplied by the hepatic portal vein and the hepatic artery. The hepatic portal vein comes from the alimentary canal, and the hepatic artery, the one branches from the aorta from there. Now class, functions of the liver. Let's start with the first function of the liver: regulation of blood sugar level. And we know, class, that the normal blood sugar level in the blood is 90 milligrams by 100 cubic centimeters. And therefore, class, we say fluctuations do occur as to the blood sugar level can go beyond the normal and can go below the normal. And therefore, as discussed earlier, that the body has some corrective mechanisms that restore the deviations from the normal. And therefore, class, liver plays a significant role in regulating the blood sugar level. Now, how does it regulate the blood sugar level is what we want us to delve deep into it. Now, class, we say that fluctuations do occur such that the blood sugar level can go beyond the normal, as well can go below the normal. So what are the corrective mechanisms that restore these deviations from the normal back again to the normal? Now class, how are these fluctuations coming about? Number one, it can have an increased supply or increased utilization. When we have increased supply, the blood sugar level will increase, and when we have increased utilization, the blood sugar level will go below. Now, liver controls the level of glucose in blood through two hormones, and these two hormones are the hormone insulin and the hormone glucagon. Now, functions of insulin are antagonistic to the functions of glucagon. What do we mean by that? If here we say increases the rate of breakdown of glucose to release energy, in glucagon we are going to say it reduces the breakdown of glucose to release energy. Now, in this case we are saying conversion of excess glucose to glycogen. The other one we are going to reverse, you see, conversion of glycogen to glucose. And when these two hormones are working on such a basis, we say that the functions of hormone insulin are antagonistic to the function of hormone glucagon, meaning when this one tries to increase the blood sugar level, the other one tries to reduce it. Very good. Now, let's start with the first thing. Now we say increase of blood sugar level above normal is detected by beta cells of the pancreas, which secrete hormone insulin. Increase of blood sugar level above the normal is detected by the beta cells of the pancreas, which secrete hormone insulin. Now, what does hormone insulin does? Hormone insulin class increases the rate of breakdown of glucose to release energy. It also converts excess glucose to glycogen for storage. It inhibits conversion of glycogen to glucose, conversion of further excess glucose to fats for storage. That means in blood we have high amount of glucose, and therefore we need to reduce these ones, and therefore these are the ways in which the hormone insulin work. Now, on the other hand, we say fluctuation can be above or below. Now we discussed when the blood sugar level is above normal, hormone insulin will be produced, and this hormone insulin is produced by the beta cells of the pancreas, and this hormone stimulates the liver to do the four that we have mentioned. None among them is breakdown of glucose to release energy, conversion of glucose to glycogen, inhibiting conversion of glycogen to glucose, and conversion of excess glucose to glycogen to fats for storage. Now again, on the other hand, what happens when there is decrease of blood sugar level below normal? Now, when there is decrease of blood sugar level below normal, it is detected by the alpha cells of the pancreas, which secrete hormone glucagon that stimulates the liver cells to do the opposite as insulin. Now, this when you say they convert glycogen to glucose, they reduces oxidation of glucose, or rather breakdown of glucose to release energy, conversion of fats to glucose. Now, this means that the blood has little amount of glucose, and therefore we need to supply more glucose into the blood, and therefore we need to do a mechanism that gives us glucose. And this one means that the blood was having high amount of glucose, and therefore we need to get to stop any activity that was causing high amount supply of glucose into the blood. Now, that aside, let's come to the deamination. Now class, in deamination, what happens is excess amino acids are broken down by removal of amino group and the carboxylic group, and that is the deamination. Deamination basically is the removal of an amino group and the carboxylic group in an amino acid structure. And in an amino acid structure class, we have the amino group, we have the carboxylic group, we have the hydrogen atoms, we have also the R group. And therefore class, deamination basically involves removal of the amino group and the carboxylic group. And how is the amino group removed? And how are the carboxylic group removed? We are going to see it here. Now class, the amino group combines with hydrogen. It combines with hydrogen. The amino group combines with hydrogen, forming highly toxic ammonia. The amino group combines with hydrogen, forming highly toxic ammonia. This is the amino group, and this is the hydrogen. It forms the ammonia. Now, this ammonia immediately undergoes the ornithine cycle. Now, in ornithine cycle, ammonia will combine with carbon 4 oxide to form urea. In ornithine cycle, ammonia will combine with carbon 4 oxide to form urea. Now, urea class is being excreted with urine as a waste product, or can as well be released with sweat as a waste product. It can be released through urine and can also be released through sweat. On the other hand, what happens to the carboxylic group? The carboxylic group is converted to glucose or carbohydrates, then oxidized to release energy, or rather converted to neutral fats and deposited in adipose tissues. And that is briefly about the deamination. How do you tell us about the deamination? You tell us excess amino acids are broken down to amino group and carboxylic group. And in an amino acid structure, we have the carboxylic group, we have the amino group, we have the hydrogen atoms, and we also have the R group. And therefore, class, when you also have you need to understand that the removal of the amino group and the carboxylic group is what is referred to as the deamination. Now, what happens to the amino group? The amino group combines with hydrogen to form ammonia. Now, this ammonia immediately undergoes the ornithine cycle, where it combines with carbon 4 oxide to form urea. Now, this urea will be removed as a waste product through urine or through sweat. Very good. Now, what happens to the carboxylic group? The carboxylic group, on the other hand, is converted to glucose or carbohydrates, then oxidized. Glucose is the building blocks of the carbohydrates, or the simpler molecules of the carbohydrates, and the carbohydrates are the complex molecules. Very good. Then they are oxidized to release energy, or they are converted to neutral fats and deposited in adipose tissues where they are stored. Now, hemoglobin elimination is also another factor, also another function of the liver. Now we say worn out red blood cells are broken down in the liver by Kupffer cells, and residual pigment urochrome excreted through urine and gives it a yellow tinge color. Now class, you can be asked, what gives the urine a yellow tinge color? The yellow tinge color of the urine basically comes from the breakdown of the worn out red blood cells by the Kupffer cells in the liver. Now when these worn out red blood cells are broken down by the Kupffer cells in the liver, now we have some residual pigments called the urochrome. Now these residual pigments called urochrome class gives the urine its characteristic yellow tinge color. The characteristic yellow tinge color. That aside. Now let's look at hemoglobin. Now class, hemoglobin is broken down into two, that is the heme group and the globin. Now what happens to the heme group and what happens to the globin group, and which one gives the feces its characteristic brown color? Now we say the globin is digested into amino acids. The globin is digested into amino acids, while the heme is changed into biliverdin and bilirubin, taken to the gallbladder, then released into the gut as bile. Right? We say that the heme group is changed into biliverdin and bilirubin. Now, once they are changed to biliverdin and bilirubin, what follows next? They are taken into the gallbladder, then released into the gut as bile. They are taken to the gallbladder and then released into the gut as bile. Now, they are then passed out through feces. They are then passed out through feces and give feces its characteristic brown color. And that is briefly about the three functions that we have so far highlighted. You also have further functions, that is the thermoregulation, bile elimination. We are going to look at them in our next lesson if we get time. Meanwhile, stay tuned, and always we do marvelous and exceptional things that will take you to greater heights in the academic ladder. Thank you very much.